Hey everybody, I hope that you're doing well. So last class we did our part 1 of our problem solving. Okay? And that was the fake word problems, where you didn't have to create a formula to be able to solve them. We were giving you formulas, or you had to understand. We did some percentage problems, and then we just used plugging into the interest formula, and then similarly using the calories formula, which will be given to you. You don't have to memorize that one. And then the revenue break-even function stuff, where we had to solve. Today we're going to do real problem solving, real word problems, okay? So this is the real deal. So what we need to do today is we're going to need to work on a method for doing real problem solving, okay? So what we're going to do first with all these is define a variable. When we define a variable, what we mean is we need to say x equals something. Okay, we have to figure out what that something is. It's pretty easy to find because usually this is what they're asking about in the question. What they want in the question. So if you can read the whole thing, then read the question part, wanted and question. You could figure out what the variable should be. We like to define the variable because that's what we're going to use for the next step when we need to write the equations. Okay? So you're not going to be given equations this time, you're going to need to write some. And they're going to need to relate your variable with other given information, with other numbers. Okay? And you're going to have to think hard during this part. This is the problem solving part of the problem solving. And then finally we're going to solve and provide our answers. So, pretty much 3 steps. For each one we're going to want to define a variable, write an equation, and solve. So let's jump right into it. Okay? So we could see something like this that play a lot on words. So it's going to just describe 3 numbers. Okay? And we're going to want to figure out how to define a variable and how to find what the 3 numbers are by writing equations. So it says, look, the second number is 3 times the first number. A third number is 115 more than the first number. If the sum of the 3 numbers is 190, what are the values of the 3 numbers? So when we have one like this, it's not really the same as the other word problems we're going to do, because they're asking us for 3 things. So we're going to want to try to base this off of one number. But if you look at it, we get a description of the second number and the third number based off of the first number. So because that's what it's based off of, it says the second number is 3 times the first. It's based off the first. That's actually what we're going to define and let be our x. We're going to let the first number be our x. And then from knowing that it is x, we can build the other 2 numbers. So let's read just the first sentence, ignore everything else. The second number is, so this one is 3 times the first number. Okay, so 3 times, well, do I know what the first number is? No, what are we calling it? X, so 3 times the first number. So that's actually pretty easy. Let's see if we can define the third number. A third number is 115 more than. Remember when we worked on writing words and expressions, going back and forth, more than meant adding. So we're adding 115 onto something. What are we adding to? The first number. What's the first number? I don't know it. We just let it be x. So there, I'm now able to define all 3 numbers based off of the first number. So all 3 numbers are x, 3x, and x plus 15. So that's part A. It says define the numbers algebraically. That means with equations, with x's, using x, and fill in the chart. Okay. Now the second part is to set up an equation and solve. So let's see. To set up this equation, what do we know about how the 3 numbers relate? you were given one sentence that tells you how the three numbers relate. That the sum, that means if you add all three numbers, you should get 190. So you don't have to write it this way, but I'm going to go. So like the first number plus the second number plus the third number should equal 190. And we happen to know what the first, second, and third numbers are, at least how we're going to represent them. The first number is x. The second number is 3 times x, or 3x. And the third number is x plus 15. So I'm just replacing that equals 190. I'm just replacing each one with its own representation. So that's the formula that relates all the numbers. So what I can do here then is that's all the word problem work. Now it's just back to solving. We have an equation we can solve. So you can run through those 4 steps that we discussed the other time. Are there any fractions to kill off? No. Don't have to worry about it. Is there anything to simplify? Yeah, there's like terms. X plus 3x plus x. That's 1x. 3x's make 4x plus another. That makes 5x's. So I can simplify. Remember, simplifying is 2 steps if there's any distributing in any like terms. All right. Do I have to worry about x's being on different sides of the equation? No. So now I can just solve. So simply solve this thing. Subtract 115 from each side. Okay. So let's see. I guess I'll keep writing in blue. So 5x equals, let me think, what's 190 minus 115? That's 75, isn't it? I'm trying to do that in my head. Yeah, I believe that's 75. Now I need to divide both sides by 5. Let's see, sorry, it was changing something over here. Divide by 5, and x will equal 15. Alright, awesome, we found x. What's the question, though? We have to make sure we answered the question. Solve. Okay, we did. Right here, what are the values of the 3 numbers? All I have is x. Could I find the 3 numbers? Yeah, actually I can. I can find all 3 numbers because I know how they all are related to x. So you're going to want to tell me. So the first number was x, which is just 15. The second number was 3 times x, which is 3 times 15, which is just 45. And the third number was x plus 115. So 15 plus 115 is 130. So we were able to find all 3 numbers. So this one's kind of like a logic puzzle a little bit, but there's a mathematical way to put all the pieces together. All right, so those are our 3 answers: 15, 45, and 130. Okay, let's go on to our next problem. All right, so we're going to need to, once again, set up an equation, first define a variable, set up an equation, and answer the question. Okay. So let's look at this. 2 cars start at the same point and travel in opposite directions. So let's kind of draw what we have. 2 cars are starting at the same point. Beautiful car, I know. Don't be a hater. They look more like UFOs, but that's okay. Drawing on this little sketch pad's not the easiest. And they're going to travel in opposite directions. Okay. One car travels 4 miles per hour faster than the other. Okay, we'll deal with that in a second. And in 2 hours, they are a total of 208 miles apart. Okay, let's find out how fast each car is traveling. Alright, so what we're going to have to do here is define a variable. I'm only trying to define one variable. So what we're going to need to do is define a variable for, well, what are they asking for? How fast is each car traveling? Let's just let one car be traveling x, and we'll figure out some way to relate the other car. Okay, so let's define this variable. X equals speed of one car. Okay, x is how fast a car is going. However you want to word that. I'm just going to put speed of one car. Okay, awesome. Now, are there any relationships that relate, or any equations that relate speed, distance, and time? Those are the only informations we have. And yeah, actually there is an equation. You need to know this. I don't believe we're going to give this to you on the test, so you need to remember this. That distance is equal to rate times time. Okay, it's a very important equation. Distance is equal to rate times time. Now, if you look at what we have here, we have two distances. Oh, let's change colors. Two distances added together to equal 208. So we have this person's distance plus this person's distance. So if I could get a rate and a time for this person, that would be their distance, and add it to the rate and the time for this person, that would be their distance, then I could have an equation to relate everything. Okay? So I know that these two distances add up to 208. From a picture, hopefully that makes sense. So look, I actually have a rate for this guy. He's traveling x, and I actually have a time. They both traveled 2 hours. So that's great. Do I have a rate for this one? Yeah, I kind of do. So one travels 4 miles per hour faster. So if this one's x, this one would be x plus 4 miles per hour more. So let's see. That means if I could just add their two distances together, let's call them distance 1 and distance 2, they need to add up to 208. A distance, remember, is just a rate times a time. And I happen to know the rate and the time. So the rate for the first one is x, and the time is 2. A rate times the time. The rate for this one is x plus 4. We'll put it in parentheses. And the time is also 2, because they both went 2 hours, for a total of 208. Okay, so I'm going to stop for a second and make sure you are with me. This all comes from understanding that distance is equal to a rate times time. The only way I have to relate these two cars is that I know they traveled apart. So if I add their two distances together, it should equal 208. So add their two distances together to equal 208. And then I say, okay, distance, that's rate times time. Distance is rate times time. So I get their two distances written as a rate times a time. Now I didn't know their rates, so we just called one x. And I knew the other car was 4 faster. And I know the time is 2 hours. So now I just have this equation I would like to solve. But before I can solve, I need to simplify, and then I can find out what x is. So let's see. 2x times 2, that's just 2x plus, and I can distribute this 2. That'll be 2x, and 2 times 4, so plus 8 equals 208. And then I have like terms here. 2x plus 2x is 4x plus 8 equals 208. And then I can solve. Subtract 8 from both sides. So 4x equals 200. And finally, divide both sides by 4. X equals 200 divided by 4 is 50. Alright, now stop for a second, smile, be happy we found x, but we haven't answered the question. Okay, if I scroll up, let's read the question again. It says, Find how fast each car is traveling. We found x. What the crap is x? Oh yeah, look, we defined x, so we know what x is. So x is the speed of one car. So one car is traveling at 50 miles per hour. The other at, well, do I have any way of finding the other one? How did the other one relate? Oh yeah, the other was just plus 4, x plus 4, 54 more, so 50 plus 4 would be 54 miles per hour. So now I've answered the question. How fast are the two cars traveling? 50 miles per hour and 54 miles per hour. Okay, I hope that makes sense. And it all comes from being able to relate things with equations. Okay? Alright, let's move on to another example. Ooh, so let's say I have the area of a triangle. So let me draw a triangle. And we always figure area with base and height. Height and base. So it says the area of the triangle is 21 square feet. And its base is 14 feet. Can we find the height of the triangle? So once again, if you look at what they're asking for, that's going to be the easy way to define what x is. Asking for the height of the triangle, so let's let x be the height. Or x equals the height of the triangle. I'm just going to go with the height. We know what we're talking about here. Okay. Now look at what we know. We know the base is 14 feet. And the total area is 21. Do we know the formula to relate area and base? Let me show you over here. Once again, it's another one you need to know. Remember, the area is 1/2 times base times height. So let's plug in the pieces we know. We happen to know the area is 21 feet squared, and we happen to know the base is 14. So let's see what we got. We got 21 equals 1/2 times 14 times height. I don't know what height is, but I'll let that be x. Okay, awesome. Now, let's simplify. I can multiply 1/2 times 14. 1/2 times 14 is 7. Bring down the x. And now it's a simple one-step solve. All I have to do is divide 7 over. So 3 equals x. So I have found x, but I have not answered the question yet. The question is, what's the height of the triangle? What is x again? Oh, that is the height. So let me write that out. So the height is 3 watts. I need units. Let's see. Feet. Everything's in feet. So 3 feet. The height is 3 feet. Awesome. So we found the height of the triangle. Okay, so make sure you know 1/2 base times height for area of a triangle. Alright, I believe this is our last one we're coming up on here, okay? So it says that we have these two shapes, and we need them to have the same perimeter, okay? So we want their perimeters to be equal, to be the same. Remember, perimeters just add up all the sides. Okay, one of them is a square. Now what's special about the sides of a square is that all 4 sides are the same length or equal. So to find perimeter, instead of doing side plus side plus side plus side, remember I can lazily say the perimeter of this is just 4 times its side. Okay? So the other shape is a equilateral triangle. That means the 3 sides are equal. So instead of doing side plus side plus side, the perimeter I can just say is 3 times the side. I'm trying to make these look like S's and not 5s. Okay? Maybe I'll just write the word side. There. Alright. So now, if we look, it tells us each side of the triangle is 4 centimeters longer than each side of the square. Find the length of each frame. So we're looking for the length of these sides. So let's just notice that it tells us the triangle is plus 4 whatever the square is. So let's just let x be the side length of what's that thing called, of the square. Okay. Side length of square. Okay, so let me switch colors here so we can see this. So one of these is x. One of these is going to be 4 longer, so x plus 4. Okay? Is everybody okay with that? Now, how do these two things relate? They relate in that we want the perimeters to be the same. So the perimeter of the square has got to equal the perimeter of the triangle. Well, how did we find the perimeter of the square? We multiplied the side by 4. What's the side length here? X. How do we find the perimeter of the triangle? We multiplied the side length times 3. What was that side length? X plus 4. Okay. So now let's simplify. That's 4x. Let's distribute here. That'll be 3x plus 12. Okay, awesome. So I've simplified. Now I got to get my x's on the same side. So subtract 3x on both sides. So 4x minus 3x is just 1x, or just x, equals 12. So I found x. But remember, I got to answer the question. Find the length of each side. So the square side is x, which is 12. 12, let's see, centimeters. Find the unit somewhere. And the triangle, whoops, side is x plus 4. So 12 plus 4, which is what, 16 centimeters. Okay, so that's why I write all that stuff down, so I can go back and look at it. I like to label on shapes and drawings like I did on the car one. If I could draw it, it helps visualize it. Also, I need to know what x stands for. I circle it once I find what x is and use that whenever I go to answer the question. Then I always reread to make sure I answer what they're asking for, what they're looking for. All right? Awesome. Well, I hope you have a good day, and I will see you next time.